So for 7.2 part 1, we're going to look at adding and subtracting rationals. Your essential question is, how can I find an LCD and add or subtract rationals? So let's look at our steps for adding and subtracting rationals. First thing you want to do is find a common denominator. We're going to work on that a little bit more later in the notes. Then you're going to rewrite the fractions with the common denominator, add and subtract to the numerator, and reduce. Let's go ahead and start by adding and subtracting two rationals that already have a common denominator. So we're going to start off pretty simple on your notes here. If I'm going to add and subtract these two, the first thing I need to check for is that they have a common denominator, and these guys do. They both have a 5. So the minute you get a common denominator, you're ready to go ahead and carry this across and put them together. So the rule of thumb is that you add the numerator, so in this case 3y plus x. Well, 3y plus x is actually 3y plus x. You can't put them together. Divided by, and then you just carry over that common denominator. It doesn't change, you don't add it, you don't multiply it, you just carry it over. Now there's one added change I'm going to make to this, and that is that I'm going to switch that x and that y to keep them in order by alphabet, and that would be your answer. I can't factor to reduce, so I'm done. For your second example, I want to go ahead and look at something a little bit more complicated. So let's go ahead and look at 4 over x squared plus 2x minus 8 plus x over x squared plus 2x minus 8. Now once again, these both have a common denominator already. We're going to work on getting a common denominator in a minute. But these both already have a common denominator. So we skip step 1, we go to step 2, which says go ahead and just add those numerators. So 4 plus x is just 4 plus x. And then carry over that common denominator. Remember, it doesn't change as is. Now this actually can be reduced, and the reason I know that it can be reduced is because it's a quadratic in the bottom, so I know that it can be factored. So if I go ahead and factor the bottom, it's a shortcut. It looks like I need two things that multiply to negative 8 add to positive 2. I get x plus 4 over x minus 2. Now, although these look a little different, 4 plus x and x plus 4 can be canceled. They're the same thing. Look at it this way. The x is positive here, the x is positive here, the 4 is positive here, the 4 is positive here. They're actually just in a different order. These are not opposites. Opposites would be if there was a minus sign. These are pluses, these are not opposites, giving me an answer, a final answer of 1 over x minus 2. So if we go ahead and look at actually finding a common denominator, which is our next step here, what we have to talk about first is the difference between the denominators you're going to see. So sometimes you're going to see monomials as part of your denominators, and sometimes you're going to see polynomials. So if you see a monomial, what you're basically going to do is just follow these steps. So the first thing you're going to do is find the common denominator between the numbers. So in other words, just what we did, what you've done before in the past, you're going to find the common denominator between the numbers, the smallest number they both can be, and then you're going to find a variable to the highest degree. So that's how you find the common denominator between monomials. If you're looking at polynomials, it's a little bit different, and this is new. If you're looking at finding a common denominator between multiple polynomials, you're actually going to factor each separate polynomial, and then you're going to use all of the pieces, but you're not going to repeat any multiples, and I'll show you what that looks like in just a second. Okay, let's look at a pair of monomials first. So let's say that I give you 5xy squared and 2x cubed y. Let's say these are a couple of denominators, and I'm asking you to find the common denominator before you add or subtract. Well, the first thing you want to do is look at your numbers. So you have a 5 and a 2. And what you're looking for is the number that they both multiply into. In other words, you want the smallest number that they both can be. Well, a 5 and a 2 can actually both be a 10. Then you start looking at the variables, and you start looking at the variables each separately. So let's look at x's first. We have an x1 and an x3. You want the biggest one. So between an x1 and an x3, the biggest one is an x3. Then you look at the y's. Between a y2 and a y1, the biggest one is a y2. That would be our common denominator, or our LCD. So let's go ahead and look at a couple polynomials since we just did a monomial. If you're given a couple polynomials and asked to find the common denominator, the first step is to factor both of them. So we can use a shortcut here. And it looks like we're looking for two things that multiply to negative 8 and add to negative 2. So in this case, negative 4 and a positive 2. Over here on the second one, we're looking for two things that'll multiply to a 2 and add to a 3, so a 2 and a 1. Now the LCD, when you're actually determining the LCD, you're going to actually use each piece, but you're not going to repeat any multiples. So for example, I'm going to use this y minus 4, and since it's not repeated anywhere else in any of these factors, I'm going to go ahead and just carry it down. I need to use a y plus 2, but since it's repeated right here, I'm actually only going to write it once. I only need one of those. I don't need to write my multiples. And then here, I need to use my y plus 1, and since it's not repeated anywhere else, I'm going to carry it down. So the denominator between these two polynomials is y minus 4, y plus 2, and y plus 1.